So today we're gonna be going over 6.5 properties of logarithms. I'm gonna refresh it as we go through these. So I guess real quick, what I'm gonna show you, this page right here is from Blackboard. When you go to our course materials and go to chapter 6, it's the first thing that pops up under the old link to the videos. And then scroll down to, this is 6.5, I believe. Yes, properties of logarithms. And this is what we're gonna be using during this lesson. They're not as crazy as it seems, but it's useful to have it on hand. So I think you should definitely use this when you're taking your test. And I'm gonna fix it again. But this is that paper that is on Blackboard. If you notice there's not one for 6.6, it's because 6.6 kind of puts all of what we've been doing together. So there's gonna be exponential and logarithmic stuff, and we're gonna be going back and forth. And we'll have to be using properties too, so I might add to it and make it better. I don't know why it's gray now. What did I do? Okay. And we're gonna need this for a couple of them. I guess let's go. I hope y'all can see that. I don't know why it's grayed out. Okay, so starting with number 1, they're telling us in the directions, write the expression as a sum and or difference of logarithms. Express powers as factors. We don't have any powers on this one. It'd be your exponents, your powers. But we're using the sum and or difference of logarithms. So if it's multiplied right here, it's going to be this property. So when it's multiplied, we have m times n. We change it to a sum of logarithms. So we're gonna break it apart, whatever's first plus whatever's second. So I have 625 times x. So my first one's gonna be 625 and my second one's gonna be that x. So let's go ahead and write that out. So I'm gonna have log base 5, 625. And then it's plus because it's multiplied here. When it's division, we subtract. And then log 5x. So your base stays the same in these, it's just you're breaking these two apart. This one simplifies a little bit more because this 625, 5 and 625 here, this reduces to a number. So 5 goes into 625. I believe it's 4 times, we'll double check though. 5 times 5 is 25. Then 5 quarters is 125, and if I have $1.25 5 times, that's gonna give us our 625. So this right here is gonna simplify to 4. You can do your base change if you don't remember that over here. I've already typed it in, and I don't like pulling up the log every time. So 625, remember it's big over the small, and then I'd put my 5 here, so that's gonna give us that 4. This one, since it has x, it's not gonna reduce, so I'm gonna do 4 plus log of 5x. And that's pretty much what this lesson is gonna be about. We're gonna be doing those sum or differences. There's a couple at the end that have like multiple parts, like there's something being multiplied and something being divided. There's a couple of base change problems, but it's not a bad lesson. It's just getting you used to using the So here it is wrote out the natural log of e times x minus 3, and that's what it is. So this is still being multiplied. It's e times x subtract 3. If it's not broke apart like two logarithms here, like we have addition and then subtraction, it has to be like there's two logs there. Like it has log this, subtract log that. This is just the natural log of those two multiplied. So when I separate these two, I'm going to have the natural log of the natural number, and then this is still multiplication here, so plus the natural log of all of that x subtract 3. It looks weird, try not to overthink this. Right here though, whenever you have the natural log of the natural number, these two cancel each other out. There's a little thing here, like if you have the logarithm base and it's 1, it's always 0. If your base and your whole number are the same, like if I had log 5 of 5, that's just 1, and you have to simplify it. So right here, remember natural logs don't have bases because that would be the log of the natural number. So what I'm trying to say is this right here is log with the base of e. And then we're using e. So right here, this equals all of it together is just 1. So when I type in this answer, it's just going to be 1 plus the natural log of x minus 3. That was a lot of words. I hope it makes as much sense as possible. Remember, it's natural log, so ln, not in. I'm going to say that on every lesson because I get lots of emails on that. I think it's going to be easier just to erase. Alright, here's our first one that has a power. So it's e to the 4th power. Let's go ahead, this is our first difference problem as well. So when you're doing the difference problems, it really matters order because subtraction matters. When we're adding things together, you can put whichever one first or last. It's not going to change it. Subtraction does. So it's always going to be top, subtract, bottom. So let's write that part out. Natural log of e to the 4th, subtract the natural log of n. I should not have wrote so big. Okay. Then these powers, what it's saying, express powers as factors. So when we have a power, it brings it to the front. It's the same thing, we're just rearranging this. So I'm going to go ahead and move it forward, and I'll leave natural log of e, subtract the natural log of n. But we know right here that these are the same things. They're opposites of each other. It'd be adding and subtracting the exact same thing. So this right here is going to be 1. So I'm going to change this right here to 1. And I wrote too big and I don't have room. So it's going to be, here, I'll go over here. And then I can erase it off all of it. 4 times 1 subtract. The natural log of n. So 4 times 1 here, our final answer is going to be 4 subtract the natural log of n. And I don't think we have to put it in parentheses. 4 subtract ln n. Yep. Okay. I won't write as big this time. I gotta erase one thing at a time. Got it. Sometimes I think it's faster clicking, sometimes I don't. Usually when I do it, it's a mess. Okay, so separating them out first. This is a division one, so it's going to be subtraction. We're going to do top, subtract the bottom, and it's to the power 7x. I about wrote it as a big number. So when it's a power, we bring it to the front of just that one. It's just to this one, so it's not going to go to the very front. This is still here, so I'm going to have natural log of x subtract 7x times the natural log of e. Then we know that the natural log of e, natural log of the natural number is 1. So I'm going to have the natural log of x subtract 7x because this is 1. Okay, this one is multiplication, so it's gonna be the sum. And let's just break apart this first part first. So we're gonna have log of b u 5, and since it's multiplication, plus sign, log of b v squared. Then we're gonna take our powers and bring them to the front of each of their respective logs. So this one is gonna be 5 log base b u plus 2 log base b v. I think there's a problem like this that's on the final. There used to be. So you might star this one and check. Or just be sure you understand it in case it does show up. I forgot my 2. 2 log base b v. Okay. This one is division, you can see that. Don't worry when they put the full little polynomial in there, because if it's adding or subtracting there, we don't do anything with it. Like, we're just gonna spread apart this division. So top subtract bottom. So we're gonna have log base 6 top subtract bottom, so log base 6 x subtract 2. I will say whenever it is a polynomial, I always put it in parentheses. So I don't think it's this, then subtract 2. So be sure you put that in parentheses. There's a power here, so we have to bring this to the front of this log. And then bring the other one down. It didn't have a power, so I didn't need to do anything extra. And that's going to be our answer. Subtract log base 6 x subtract 2. So. Oh, here's one of them that has a couple of things going on at the same time. Like right here, this x times x plus 7, that's being multiplied, so that's going to be a plus between those two. And then we're going to subtract this. So we're just going to start with our top and do what we would normally do. So I'm going to have log of x, and then it's being multiplied by that, so that's a plus sign. Log of x plus 7. And then this is all being divided by it, so we subtract the bottom. So log x plus 2, and this is raised to the third power. So that power we're going to have to bring to the front of that log. Not everything, just this one. So let's rewrite that. Log x plus log x plus 7, subtract 3. Well, that x is funny. Okay, but yeah, one at a time. So we did our top and then our bottom. And since our top had that multiplication, we had to split it into that plus sign. Log box, log x plus log parenthesis x plus 7 minus 3 log x plus 2. Did I type that all in right? That seems like a lot. Alright, here's the ones that I had Desmos pulled up for. One thing that I realized this last time using it is once I get it set up with this, it's a lot easier just to type them in. instead of restarting each time, so like I just deleted the number that was in there, and I have 42, I'm gonna put 6 here. They want us to round to 3 decimal places, so that's gonna be 2.086 for me. And then here, instead of redoing it all, 2 is on the top because you do big number over your base number. And here I'm gonna have 1 over 5. And so it's gonna be negative 0.4306. So I'm gonna round that up to 431. Oh, I hit the next button. 431. Similar question. Okay. Big number is 10. Our bottom number is the square root of 2. Square root of 2. I have 6.6438, so I'm gonna round that up. 6.644. Okay, and back to properties. I hate that that's shaded. I don't know what I've done. Alright, anywho, similar question. These last two, they want us to express y as a function. We haven't used this down here, so that should be your giveaway that we're about to change things up. We're gonna use our product rule where we multiplied, and so that broke it apart to adding. So here it's broke apart right now to being added. I'm gonna multiply them, so I'm gonna have the natural log of y. I didn't do anything here. I'm just having to solve this for y. And so I'm gonna put these two together. Since it was added, I'm gonna multiply them. So I did the reverse of what we've been doing. So instead of breaking it apart to addition, I put them together in multiplication. And then the rule here says that if the logs and the bases are the same, then m equals n. So since they're both natural logs, the bases are the natural number, y equals 8xc. So I'm going to type in 8xc. Okay, this one's similar to the last one we had. The natural log of y equals the natural log of x plus the natural log of x plus 20 plus the natural log of c. Since these are all being added, I'm going to use this sum rule and put them together with one natural log because they all have the same base. And then I can say y equals x times x plus 20 times c. One of the things that gets, I guess, the most confusing with the properties is that sometimes you've never done anything like this. So it feels like it confuses you a lot more than it should. But it's okay because it's new and it's different and it's weird. But that's all that's on this lesson. If you get hung up on any of that stuff, message me so that we can figure out what's going on. Maybe I need to do some new stuff on the video. We'll figure it out though.